This video will cover the exercise for the proposed State Route 185 profile in ODOT's Open Roads Designer Training. So to get started, I'm going to open the design file that contains the geometry for State Route 185. That's my bk004.dgn. So I'll just double click to open that file, and it's going to check it out from the ProjectWise server, download it to my local machine, and then open that file for me. So profiles are stored as components of the geometry itself. And so to edit and design my profile, I need to open a profile view. So I'm going to give myself a little more screen space by just unpinning the Properties Explorer dialog. And I'm going to open a profile window. There's a couple different ways I could do that. One way I could do this is by selecting the center line itself, and from the pop-up menu, choosing the Open Profile Model. And if I want to do that, I just need to choose one of my MicroStation view windows. It doesn't matter which one. I'll use View 4 and just click in there. Looks like I had used View 4 previously since that was showing up. So that's displaying the profile by just picking the command from the pop-up menu. Another way you can do that is if I hold down the right button under View Control, I can pick two views, Plan and Profile. Now this will orient the view across the bottom of the screen, so that's one reason I kind of like that option. So I'll hit OK to create my dynamic profile. I need to pick the element and then click in the view, and it will display that profile for me. So this is a view window that's specifically optimized for the profile itself. And if I look at the attributes, I can see there's some different attributes here for a profile window. So vertical exaggeration down here lets me to set my vertical view. And you may want to exaggerate this as you're working on the profile a little bit, just to see some changes in the vertical a little bit better, especially if you have something that's really flat. You can also use the Shift button and the mouse scroll wheel to change the vertical scaling. And you can use the Control to change the horizontal, Control with the mouse wheel. Okay, there's a few other things here. I'm going to go ahead and expand this just to maximize my view of my profile. A few other things here that are new and added for a profile display itself. So I have the Fit view, of course, and then I have a Fit Profile Elements, and that one's a little different. That it's going to be based on the length of the alignment itself, and then I have a fit plan extents. So whatever I'm zoom in on the plan, it's going to approximately fit the same area here. There's a drop-down list of profile-related commands, and these commands are also available in the ribbon itself. If I'm looking under the Geometry tab in the vertical group here, you'll see those commands duplicated there. So this is just kind of a quick access to these commands from within the dialog. There's an option here to create a 3D cut, and what that does is goes out and reads the 3D model and displays anything that would cross my center line, I guess. So if I had any drainage items, culverts, utilities in my 3D model, the 3D cut would read that 3D model and display these in the profile itself. I don't have any elements in here at this time to display that, but that's the purpose of the 3D cut. And then there's a refresh 3D cut option as well. So I'm going to define my proposed profile. So I'm going to use the vertical lines between points commands. There's different commands here for lines to element, from an element, etc. So I'm just going to start with a simple line between points. And I need to choose the feature definition for this. So in my feature definition list, you'll notice in ODOT's feature definitions that we don't have a specific profile group. Actually, you're going to use the same feature for your profile that you use for the alignment itself. And that's because that feature definition has definitions for both the plan and profile information. I'll make that my active feature. Now I'm going to put in a starting point at station 386 plus 25, and I want to meet the existing ground elevation. So to do that, I'm going to use Civil AccuDraw. So I'll open Civil AccuDraw and turn Civil AccuDraw on, and the dialog expands with the options for profile. So dragging my cursor is entering a start station and a start offset. And the station is going to be relative to the location in this profile view, but the offset, I need to tell it which element I'm going to be offsetting from. So to do that, what I need to do is tab to the offset field so it's active, and then I'll type in the letter O on my keyboard, and it's asking me to select a reference element. So I'll choose the ground line, and now that is the reference element for my offsets. So we're going to start this line at station 386 plus 25 with an offset of 0, which puts it right on the ground, and I'll left click to accept that starting point. So the next point is defined by a station and an offset from the ground as well. So this one is going to go up to station 387 plus 00 and an offset of 0.25. And I'll accept that. So that defines the first part of my profile. So from this point forward, I may or may not need Civil AccuDraw. I'm going to leave it active, but if you want to turn it off, you can just turn it on or off at will using that first icon. The next point, looking at ODOT's training guide, is at station 392, and we're given an elevation of 1014.07. So I'm going to go ahead and use the Z mode in Civil AccuDraw to enter that. So now you can see it's asking me for a station and an elevation, entering the start point of the next line. So I'm going to start from the end of my first line, and the station for this is 392. And our elevation is 1014.07. And I'll accept that location and just zoom out a bit. I can see that line that's entered. So I'm going to continue entering stations and elevations using ODOT's training material with the values that are given there on page 401-2. So I'm going to start from the end of this one. And the next one is at station 398. An elevation of 998.65. Accept that. Starting from the end of that one, we're going to station 403. An elevation of 993.65. Accept that. And continuing on from the end of that one, station 410. Elevation 982.17. Pan over. And continuing from the end of that point, we're going to go to station 422 plus 50, an elevation of 966.61. And from that one, 426 plus 00, an elevation of 964.45. And to finish this off, starting from that point, we're tying back into existing. So I'm going to change my mode back to station and offset for my profile. So this is at station 427 plus 50, an offset of 0. So I've defined all the tangent lines for my profile, and now I want to go back and fit in some vertical curves. Some of these are a little flat, and that's where that exaggeration is handy to help me see some of the deflection angles of those lines. Okay, so I'm done with Civil AccuDraw, so I'll go ahead and turn it off and close the dialog. So the next thing I'm going to do is fit in some vertical curves. So to do that, in the curves group, vertical group here, the curves, I'm going to do a profile curve between elements, a parabola between elements. So it's asking me to locate the first element, so I'll pick my first tangent line, second element, pick that, and now the curve is floating on my cursor. And looking at ODOT's training material, this one should have a 700-foot vertical curve. So I'll enter that value, and it shows me the value. So I'm going to go ahead and accept that, and now it's asking me to trim or extend the elements, and I can scroll through the options using my up and down arrows. So I can trim or extend both of those tangent elements, neither one. The back tangent, which would be the first one I selected, the head tangent will be the second one. I'm going to trim both. So with it set to the both options, I will left click and it will trim those elements off. So just like our vertical geometry, it's just trimming the display of those. That intersection of those two tangents is still maintained by the software. Okay, continuing on, the next one, we have a 300-foot curve. So I'll just enter that, trim those off. Next one is also a 300-foot curve on this side. Then moving along, my next one is also a 300-foot curve. Two more to enter. The next one is a 450-foot curve. And the last one is 150 feet. And I'll just go ahead and do a fit. So you can see the symbology for the tangents is a white graphic. The symbology for the curves is a blue graphic. So we did that just to easily identify the curves in this. That's really helpful if you've got a really flat profile. So now that I have the individual elements defined that make up this profile, I'm going to complex those together. So in the vertical tools, I'll choose complex geometry. We're going to do a complex profile complex by elements. I'm going to use an automatic mode, which will chain these together, looking for elements that mate within a specific tolerance. And I'm going to name this using ODOT's CAD standards. This is my proposed line, PGL, and then underscore, and then the name of the plan view alignment. So that's CLP underscore S185. So it's asking me to locate the first element, so I'll pick that first tangent, and it's going to highlight all the elements, and I'll accept that to make that a complex element. I can verify that that's one element by selecting the graphic, and I can see everything it highlights. All the different rules are there that can be edited if I needed to come back and edit that. Now that I've defined this profile, I'm going to set this as the active profile. So to do that, I'm going to use my element selection tool, select the profile element itself, and then wait for the pop-up menu. And the second icon is set that as the active profile. There's a few other tools on the pop-up menu. These are covered in ODOT's training material, but one of the tools I want to show you is the profile report. So I'll go ahead and pick that. This is going to open a generic report. These are developed and distributed by Bentley. These are not ODOT customized reports. So the vertical alignment review is the default report coming off of vertical alignment, and there's the information that's displayed in that report. The format of the report can be customized by picking tools, format options. And I can change things like on slopes, the number of decimal places that I want, whether I want it to be in a percent format or rise, run, rise, etc. Stationing, how many decimal places do I want? Do I want a plus sign in my stationing, etc. So once I configure these and close that, the settings are dynamically applied to the active report. And these reports can be saved using the file save as command to save it as a Excel or Word format or some various formats. So it's just a quick overview of the report function. So at this point I have my profile defined, and and that has now been set also as the active profile. So I'm going to go ahead and save my file, and then when I'm done I can exit the file, and I'm going to check that back into ProjectWise. So this completes the exercise for the State Route 185 proposed vertical alignment.